Hi all, this is Vinod and this is project 2 and class 2 in the series for predicting the hospital readmission using machine learning. This is going to be a practical session and you can refer to the below given URL for more information, and you can also give me a call back on this number in case you need any help, and also request you to please like and subscribe to our videos. Let's switch back to my Jupyter. Okay, so I have imported pandas for doing the various operations in our data. I have imported NumPy as NP. I have imported Matplotlib for for various visualization graphs and diagrams. I have imported time, and I have imported my CSV file, right, using pandas read underscore CSV method. And this CSV file basically contains record of all the diabetic patients. So if I open this file, how does it look like? So let me open. So you can see here that it has the encounter ID, which is nothing but any encounter the patient has gone through, the patient number, the race, the gender, the age, the respective weight, admission type ID, the discharge disposition ID, diagnosis 2, diagnosis 3, the number of diagnoses which has been performed, and which all medication has been given. And no means there was no medication given. And study, it was study, and these are all the medication which has been given to the patient. And I quickly go to the right. Change, it means no means there was no change in the medication, and CH means there was a change in the medication. Diabetes medication, yes. No means there was no diabetes medication given. Yes means yes, it was the medication given to the for diabetes. Readmitted, no means there was no readmission. Greater than 30 means they were readmitted after 30 days, and less than 30 means they have been readmitted within 30 days. So that's our data set. Let's go back to our Jupyter. So let me import all my libraries one by one. I'm importing the CSV file using pandas read underscore CSV method. Now in case if you need to check the data, you can use df, which is our data frame dot head, and you want to print the first time record. Yeah, you can see all the data here. Let's go down. Now if you need to check how many samples, how many records you have in your data set, you can use length and you can pass on the data frame. Hit enter. It has approximately 1 lakh record or samples. Now data set. Let's go down. Numerical columns, category columns. Numerical columns which has got which are numerical. Categorical columns which are free text, which are normally a string. Right. Let's check the readmitted. So what we are doing here, we are doing a group by using by the readmitted column, and we are taking a size. Let's do this. It tells me that on the readmitted column, the number of record which has got less than 30 are approximately 11,000. The number of cases which are readmitted after 30 days are approximately 35,000, and the number of cases where there was no readmission were approximately 54,000. Right. Let's go down. Now there was one column in our data set which is discharge disposition ID, which tells where patient actually went after the hospitalization, right? And and if you look at the respective their mapping, so some of the IDs actually represent death or hospice, um, and which has no relevance to our prediction model, so we can remove those IDs. So if you look at the ID number 11, 13, 14, 19, 20 and 21 are actually represent death or hospice, right? uh, so what we have done, uh, let's understand this equation, this syntax. It says the discharge disposition ID, which is our column name, is having is in. It means it's having, you know, the IDs, these 11, 13, 14, 19, 21. um, and so if I simply copy this, Control C, and I put it here. False means there was no ID, like like in from any one of these, and true means there was some ID. And if I go down and put a negation, so it will do the other way around, right? And if you need to find out the location, so if I put df dot location and I pass on this, so it gives me all the record where the ID is not 11, 13, 14, 19, 20 and 21, because that's what we need to exclude, right? Because they all represent death or hospice. So that's our data set, and that's what we have done here, and we have assigned this to DF, right? Let's enter. Let's go down. So now we are creating a new column named as output underscore label, and here we are saying that wherever the readmitted is equal to less than 30, and we are converting that into an integer, right? So if you run this, so what we see in the output label, so we can print, right? So we can check the value count of the values in this column, and so use the value underscore count. We put normalize true into 100 means we need to show this as a percentage. So if I run this, it tells me that the number of record having 0 in the output label is approximately 88%, and the one value in output label column is approximately 11%, right? So we can see there is a high number of record having 0 as the output label in our data set, right? Let's go down. So now we can see, I mean, the data is imbalanced because there are more number of no readmission cases in our data set, and very less number of cases of readmission, which contributes to only 11%. So we know our data is imbalanced, right? And counter ID and patient NBR are just identifier because they are not making any contribution from prediction perspective, and they also don't provide much information, right? So if you look at our column, so we write df dot columns. It gives me all the columns in our data set, and you can also see the additional column that we created is output underscore label is also a part of the columns. Let's go down, and if you look at these two columns, the Examed and the Sitogliptin, they both have equal values, and so we can remove them from our data set. So we are checking wherever, if you need to check if this value in examate is equal to this, so we use dot equal method, right? And if I do this, it tells me it's true. True means it means both the data in this column and in this column are same, right? Now we have seen that there are three columns in our data set: diagnosis 1, diagnosis 2, and diagnosis 3 are all categorical, have a lot of values, right? They're all numerical numbers. We will not use this as a part of this project, but you could group these ICD codes to reduce the dimension. There are lot many different kind of codes you will see in these three columns. So we may not be using all the ICD codes, but I think we can group them together. You have to have a lesser number of codes. So for that, what we are doing, we use the number diagnosis to capture some of the information. Now coming to the feature engineering. Now what we are doing here, that wherever you might see in your data set, some of the values are shown as question mark, right? So we'll replace this question mark with not a number, NaN, right? So in our data set df, we are replacing wherever it finds question mark with NaN, which is a numpy method. So np.nan, and let's do this. And if I need to check the initial 10 values using head method, and you can see that the weight which has initial question mark, now the values are being replaced with NaN, right? Let's go down. Now if you need to check the information about your data set, you can use df.info. So info will give you all the information about your data set. For example, you can see all the columns, whether they are null or not null, and what is their respective data type, right? Integer or object. Object is as good as your string, and it has got 51 columns, and the index value are starting from 0 to 101765, and it has got 99 343 record or samples. Let's go down. Now we are getting a list for the numerical columns. So time in hospital, number of lab procedures, number of procedures, number of medications, number of outpatient, emergency and inpatient visits, and the number of diagnoses. So we are all taking them into a list, and we are calling as a column underscore num. Let's hit enter. Okay, just to keep a check on the time, let me go down. Now we're checking if there's any blank values in our data set. So in these numerical columns, so we are passing df, these columns, a numerical column underscore num, which is our this list, is null, and we're taking a sum, right? So it gives me a sum if the are any null values, and we can see here they're all 0 as a sum. It means there's no null values in our in these columns. Let's go down. We're talking about the categorical feature, which are nothing but our which are not which are actually non-numeric data. So we are getting a different list for categorical columns, starting with race, gender, and all the medicines, right, till the your change or diabetes, medication, pairs code, medical specialty. They're all part of the categorical columns. Let's enter. And in case if you need to check only for these columns, so you can just give the name of that list category columns. We only show you the data for those category columns. Let's go down. Now again we are checking if there is any null value using isNull and some method in these category columns, and we can see that race has got some null values, which is 2, 2, 3, 4. And if you go down in the pairs code also, we can see the 39,000 blank values and approximately 48,000 in the medical specialty. So there are still some blank values in our categorical columns. Let's go down. So wherever you see that there is a blank value, we are filling it with U and K, unknown, right? So here we, in the medical specialty, we are using .fill NA, will fill all the null values with U and K, right? And similarly in race and similarly in pairs code. Run this, and if we need to print only for medical specialty, you can see here the couple of values which has got none. NaN has been replaced with U and K, right? Let's go down. In case if you need to check if there is any, if what are the unique values in any specific columns, you can use the nUnique method, and you can give the that column name, right? So it tells me that there are around 73 unique values in medical specialty, right? Let's go down. Now here, so we are doing a group by using on the medical specialty, and taking account using size method, and we are sorting this using using sort underscore values in the descending. So where the descending is false. Let's do this. So you can see this was the size of different values within medical specialty, and we can see that unknown is it's approximately 48,000, followed by the internal medicine. Let's go down. Now here we may not be considering all these the medical specialty. We only be considering the top 10 values in the medical specialties. And let's go down. So what we have done here, so we only consider the top 10 medical specialty, and we have listed, we have created a list, right? And we have assigned it to top 10, top underscore 10. Let's do this. Let's go down. Now using so we are creating a new column named as medical specialty, med underscore spec, and we are creating a copy of this medical specialty column using .copy method. Run this. Now here we are saying that wherever the value is not top 10, then we are replacing that value with other, right? Let's do this, and if we check on the new column med underscore spec, we can see that all other values which are not in top 10 has been replaced with U and K, sorry, other, right? Let's go down. Now as I said, df.info would give you the information about your data set. Let's go down. Now here we are creating a numerical and categorical columns for admission ID, discharge disposition ID, and admission source ID. Let's do this, and we are converting this using a as type method to the string. So all these column would now be a string. Now we would be applying the one hot encoding technique using pandas get dummies method, and you can refer to my video on my YouTube channel to understand more about the get underscore dummies method. uh, so here we have pass on the categorical columns, right? Given the numerical categorical columns, which is this, and we have given the medical specialty column, right? uh, and we have given the drop underscore first just to be true. Let's run this, and if I need to print the initial to record, we can see the respective values as we change to numerical values. Yeah, that's how the get dummies method works. And if you need to check the values for race column, we use value underscore count method. You can see how many numbers we have, in respective values under race. Yeah. Now here we are concatenating our this df, which is our initial data frame, with df underscore cat. So df underscore cat is this column which has got all the your categorical columns data set. So we can concatenating this with our original data set. At axis 1 means concatenate at column level. Do this, and you can see print the initial 10 values, and you can see that the additional columns that we created has been appended in the end. Yeah, let's go down. Now we are this df underscore cat, right? The additional columns we are putting into a different variable, which is calls underscore all underscore cat, and just to save it from future perspective. Now so I stop it here, and please stay tuned to my videos. In the next video we will be covering from extra features, and thank you so much for your time, and once again I request you to please like and subscribe to our videos. Thank you.